Right. So SSAS. So this is the SQL Server Analysis Services tool. So basically this tool why we are using for creating the cube database. So if you see in normal data warehousing, our SQL Server. So this is the database engine, and we are using to store some data, and whenever we want to retrieve the data, so we are creating a database. So who will create the database in our SQL Server normal data warehousing? A data modeler will involve to design the database. Data modeler, right? But
Alright.
we are coming to this SSAS, the schema designing and all those things we have to do. Okay, in your SQL or normal data warehousing, if you want to design a database, okay, if you want to design a database, you have to use some tools, some other tools like Visio and Erwin data modeling, ERWIN, Erwin data modeling and Visio. So these are the some popular tools they are using to design a database. For example, when our project is starting and after the business requirement gathering, the data modeler will involve to design the schema, database schema. So there are two kind
So
of,
it's a template, right? The Visio Irwin is the just template, right? They just provide the graphical representation.
yes,
That
yes. So you, by using these tools, these are the graphical user interface tools only, and inside
yes.
tools you can design the what is the table name, and what are the fields you want to, what are the attributes, means what are the column names, and what are the data types, okay, and what is the relationships. You can define the everything by using graphical user interface, because you, yes, you can do this thing in SQL Server Management Studio also, but it is not that much of clear, and that much you don't have that much of features. If you see here where we can design that one, just connect to the SQL Server database engine. So how can you see your schema designing diagrams in SQL Server?
Yeah, under databases, if you go there and you can see that, right?
Yes, you just go to the database, and under the database diagrams, okay,
Yes.
you can create a new diagram. But here you can see the existing diagrams only. How you can see? You have to add the tables, whatever the already tables we have in your database, that tables you can add into that diagram. And if you want to make relationships, yes, whatever the relationship, just drag and drop, how we are doing in SSAS data source view. If you are making that relationships, if you are saving that diagram, automatically that relationships will affect in your database. For example, if you want to create a relation between two tables, like a fact table and one customer table, previously if you don't have that relationship, it will affect that relationship in your database if you are save that diagram once you are creating the relationship. Okay, but before that we have to create the table, right? But you can't create that in a graphical user interface here. Yes, you can create, but this is not giving that much of clarity in like Visio and Erwin data modelings. So the people, the data modelers having good idea about this Erwin data modeling and Visio, so it is very easy. You also can look on that. Okay, so in
Okay.
that the data modeler will design the schema. So how many kind of schemas we have, any idea?
Uh, the schemas, I'm not sure. The tabular, I think,
No,
multi.
no, that is not a schemas. That are
Okay.
models. Okay.
Okay.
Design that model, we have to use some schemas, right? For example,
Right.
if you are coming to the OLTP system, what exactly OLTP system?
The online, what is it? Transactional processing, right?
Yes, online transactional processing. If you have a business, so daily the number of transactions will happen. Okay, for example, banks or ATMs or supermarkets. It's a live data. The customer will come to you and he will make one transaction. Okay, so direct interaction with the customer. So that transaction will happen. So whatever the transactions is happening, those transactions we are going to save inside this database. So if you want to create this database, the schema, if you want to design inside the OLTP system, so this schema, whatever the schema is nothing but the tables and what are the columns inside the tables and how you are going to make the relationships between the tables. That is the schema, nothing different. Okay. So for example, in your OLTP system, you have a customer table and product table, right? And what is the next table? Anything, date table, whatever. And so we have some transaction table. Okay, so whenever the customer is coming to your organization or your shop, your outlet, so the customer information will come into this table. So you have some front-end application for supermarket or banking. Whenever you are inserting some information about the customer, what is the customer name, customer mobile number, and what is the transaction, means what is the quantity, what is the amount. So the product information already you have. So that is in your hands. What are the products you have in your in your outlet? So that information you are going to maintain the inventory. Okay, right. So whenever the transaction is happening, what is the product he is purchased and everything. For example, the customer information is coming to customer table, and the transaction information means what is the quantity and what is the amount, and also we are going to make the relationship with this customer table and product table by using key values. Got it? So this table looks like
Got
this
it.
way: customer id comma product id comma quantity comma total line amount, that is amount, just example. And this customer table, what are the fields it has? Customer id, customer name, customer address, some other information. If you don't want to maintain all the customer related information in one single table, yes, you can maintain another table, customer detailed information, unnecessary information like customer zip code, customer marital status, and some other unnecessary information you can maintain in another table, right? So whenever the new customer is coming, so the customer information will add over here, like customer id I want to give 100, customer name RAM, and customer address something something. So what is the transaction table will get? The transaction table will get what is the customer id 100, which product he is purchasing. For example, I have a product 1 and the product name is Santur, whatever. Okay, the Santur soups. The product ID is 1. What is the quantity? 10 quantity. What is the amount? 3000. What is the date? So if in your date table, if you have date, so the date key will come here, one more column, right? So the relationship between these tables, what we are calling these tables? These are master tables. In OLTP system, we are calling these are the master tables. And this table we are calling, it's a transaction table. The table name, it may be anything. The values, the measure value, we are not calling these as the measure, the key values and the fact values, whatever. Okay, these values where you are going to maintain, that table is called transaction tables.
Okay.
In OLTP system, we are calling all this customer, product, location, store information, and date dimension, all these not dimension, we don't call the dimensions. These tables we are calling master tables. And each master
So
table,
those are, you can call it as lookup tables also, right? So those are kind of lookup tables only, right?
no, not lookup tables. These are not lookup tables. These are the master tables, and each table having a primary key column.
Which is related to the, I mean, which is mentioned in the transaction. Yeah.
Yes. So this column is going to refer the primary column of the master table. That means this is a foreign key column. This is a foreign key column, and this is one foreign key column. If you have any, for example, if you have 10 master tables, so the 10 master tables we are going to refer inside the transaction table, right? So then you have 10 foreign keys in transaction table. For example, I want to see information like, so what is this quantity and what is the amount, which customer, which product. So you have to make join with the customer table and product table with the transaction table on customer ID table and product ID table. Then you will get the information about the customer and product and how much quantity, how much amount.
So
So
does this transaction table contain the primary key also?
no.
It always contain only foreign keys?
Yes, yes. So yes, if you want to maintain some unique key value, like for example, it's a kind of a row number. Yes, you can maintain, but ideally they don't maintain any ID.
Okay.
Okay. So if you are coming to this OLTP system, there are master tables, and the master tables having primary keys, and there is a transaction tables. The transaction tables having foreign keys, those referring the primary key of the master tables. And one more thing, if you are coming to here, so these kind of schema, so whenever the people are designing this database for OLTP, they are creating master tables and they are making primary keys and they are making foreign keys with the transaction table. This kind of schema we are calling ER diagram, entity relational diagram. Okay, the approach, the modeling they are following is entity relational modeling.
Which one we call it as? So
E
sorry, could you repeat your, okay, so the master tables we call it as ER database, ER modeling database,
entire
but
thing. So that the tables and the table in between the relationship. Okay, all
okay.
this schema designing we are calling entity relational modeling. So customer is one entity, product is one entity, one real-time entity, and transaction also one entity. We are going to make the relationship between these tables, that is primary key foreign key relationship. So this concept we are calling entity relational modeling. Okay, so basically
Okay.
whenever these people are going to design this OLTP system or whatever anything, so for example right now you have an idea or you just got an information from the client, we want to start a new project about our database and some application. So right now you don't have anything. So the business requirement, the business analyst and your team leader whatever are going to participate to gather the business requirement information, BRD, business requirement document. So they will meet some people from the client side, either it is a business people or whatever. Okay, they will gather some information what exactly they are expecting. Okay, after they are designing the BRD document, they will send this BRD document to back to the client people for the acceptancy. So if there is any modifications, yes, the business requirement people, the client, from the client side people, they will suggest you some modifications. Then again you have to do, and again you have to send to the acceptancy. Once they are accepting this business requirement document, yes, then we have to start the designing, right? The project designing. In between, is there any modification required? Yes, definitely, that is a cost perspective. Okay, there is a lot of things involved to change the business requirement document. Okay, right. For example, once the BRD is finalized, the first, the business, the data modeler will come to the picture. Data modeler, if it is only related to database side. If there is any other application also we want to design, for example, the client wants a front-end application and back-end database also. So the front-end application architect, he will take care about how they are going to design and how they are going to implement the process. We are not the application people, we are just database. So the data modeler will come to the picture and he will design the schema. So when he is going to design the data modeling, there are three levels. One is conceptual level. The second one is logical, and the third one is physical. So sometimes the conceptual and logical both are same. Okay, nothing much difference between this conceptual and logical. Here first they are just identifying the entities. You have a business. What business? It's a kind of a supermarket. So basically in the supermarket, normally what kind of things involved? The first thing is you have some products, right? Yes, we can maintain some product information in the product table. So that is one entity. So daily the customers will come. Yes, the customer information we have to maintain in a customer table. That is one entity. They are just identifying the entities in this level, in conceptual level. Okay. So if you are coming to the logical level, inside this product table and customer table, and you have a location table also. For example, if you have a number of stores, the stores are in different locations in the worldwide. The location information also you can maintain. That is one more entity. And stores. So you are going to give some each name for each store to identify. So the store information also you can maintain. And employees information. So a lot of things you can identify in the concept. Just concept. This is a proof of concept. We are just preparing. They are just writing what is the entities and all those things. Then next, coming to the logical. Inside the logical, one more step. For each table, what are the information we have to maintain? In the customer table, what information you want to gather from the customer when the customer is coming and purchasing something? I want to gather the information only the customer name and customer mobile number. Yes, in the table, in the entity, you just keep customer ID, customer name and mobile number. That's enough, right? If you want to maintain some more, yes, the column names we are going to define in the logical diagram. So if you are coming to the physical, so this is the final one. What are the column, what are the entities? What entity means table name, what are the list of columns, and each column, the data type also we are going to define here. And the primary key, on which column you are going to maintain the primary key, and some constraints, some rules. For example, for a particular product, minimum two quantity of the information, minimum two quantity has to purchase, or some constraint like is not null constraint, or for example employee salary definitely it should be greater than 6,000, then only that information I want to maintain. So these kind of constraints, if you want to create an SQL Server tables, yes, you can, all these things you can define in the physical. So this is the final thing. So once your physical design also done, so you just take the scripts, the data modeler what he will do in that Erwin data modeling or Visio. So finally after making the relationships and all those things, he will take the scripts. Scripts are nothing but create table scripts and all the relationship scripts. He will take SQL scripts. He will give to
So
the
does it
developer.
generate the scripts also? Visio or Erwin, does it create the scripts of the SQL?
Yes, yes. After your graphical user interface, you are designing in GUI, graphical user interface. From
Right.
graphical user interface, he will export that information like a script, SQL.
Okay.
Okay. So the data modeler will give scripts to database developer.
Mm-hmm.
So he will take that scripts and he is coming to here and is running the scripts over here. First he will create a database, and inside the database if you are running that scripts, it will create all the tables and it will make all the relationships. Got it?
Yeah, yeah, I got it. Yeah.
So up to here this is the OLTP system. Okay. So basically,
So you
yeah.
came in the one, you asked one question about the schemas, types of schemas, right? So what are all those types of schemas? Star
Right.
schema or
So
snowflake schema? You
yes,
mean to say?
yes, yes. That is coming in a data warehousing. Okay.
Okay.
So this is just OLTP system, right? OLTP
Yeah.
system. So in the OLTP system, we are going to maintain only one kind of thing, that is entity relational modeling. Okay, entity relational schema. Okay, and if you are coming to this data warehousing, so what is our goal? Whatever the daily transactions are happening here, so only the mostly the people are maintaining based on their requirement only the 15 days or 20 days information only they want to keep over here. The remaining information they want to track and store in the historical data warehousing. So the data warehousing schema designing, like the table designing and all those things are different. Okay, so I will tell you the comparison. In data warehouse in OLTP system, the tables are, we are calling master tables, right?
Yep.
If you are coming to this data warehousing, the tables we are calling dimension tables. Got it?
Got it.
Dim customer, dim product and something. And the transaction table we are calling over here is fact tables. The values inside this fact table are measure tables, measure values. We can call it a measure table also. There is no varchar information, there is no strings information. In these tables, we have only key values and measure values. So, in this dimension table, for example, dim customer.
But the transaction table can contain, right? So just now you showed this, okay.
That is
Only
required data
quantity
model.
and amount it can be maintained, but about like a product description and all, it should be maintained in the dimension table, is it?
Yes, only the IDs, the relationship only we are going to maintain. See here, the product ID. What is the product ID? 1. The one we are going to, yeah. We don't maintain Santur directly over here. We are just maintaining the key values. Whenever you want to see the information, you just join this table with this product table based on the product ID and product ID. So it will take the corresponding value. Got it?
Yeah, yep, got it.
So if you are coming to the data warehousing, the same customer table if you are taking, so here the table name we are going to maintain like a dim customer. Okay, the fact table we are going to maintain with the fact and the table name fact sales something. So this is the primary key column in your OLTP system, right? Right.
Right.
The same primary key column coming over here. But in data warehousing, we don't call this is a primary key. We are calling this is a business key column. We are calling this is a business key column. So then where is the primary key? We don't have a primary key concept here. Okay, we don't have any primary key concept over here. So each table we are going to maintain one column, that is automatic increment column, like an identity column.
But technically those are primary keys only, right? Just we call it as a
Yes,
business key,
technically
correct?
those are behave like a primary key only. So the column name we are calling surrogate key column. Surrogate, and this is business key column.
So on top of the transaction, sorry, on the dimension side, do you have to mention any other specific one more column extra other than OLTP system?
Yes,
Like
that is the key column.
the key column will be an additional, is it? Surrogate key won't be there in the OLTP and it will be there at the
Yes,
dimension.
yeah, right. Yeah, this is the extra column, and it is automatic incremental column. You don't need to insert any data into this column. Okay, it's a
Okay.
identity column. Whenever the record is
Always?
created, yes, it will increment the record one by one, and it will insert the, for example, whenever you are creating this table dim customer, we are making the behavior like identity column. So what it will do, based on the property you have given, for example, just come over here. Whenever you are creating the table, create table dim customer, the customer key integer, so you have to put identity property. So the starting, I want to start from the 1 onwards. So each time, for each I want to increment one value. So what it will do, it will start from 1, and for each row it will add 1. So 1 2 3 4 5 6 7, like that. Okay.
But it's not the mandatory to put only identity column, right? Sometimes in our case it can be a GUID also, right?
Yes, yes. GUID also, sometimes you can, in SSIS, whenever
Mm-hmm.
we are going to load the data, so you
Yeah,
can insert that record also. Okay.
yeah, yeah.
The problem,
So,
yeah, why we are not maintaining the key value, sorry, identity column. Sometimes if you are deleting the record, okay, for example,
okay,
you are inserted 10 rows. So the value, the key column will come 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
right.
Up to 10. So if you want to delete 5 records, these 5 records. So the next
Mm-hmm.
time when the record is going to insert, it has to start from the 4 onwards, right?
Right,
But it will start from the 11 onwards.
correct. Yeah, index will be there in the book. Mm.
Yeah. So that is the reason it, sometimes they are not using the, if you have a chance to delete sometimes the data, so don't prefer this one. Okay, right.
Which one do we don't prefer? Which one we shouldn't prefer?
Yeah, sometimes you have to delete some data unnecessary.
Correct.
So in that situations, yes, don't
Which approach? Sorry, didn't get you. This is going to be inserted by the auto increment, right?
yeah, auto increment identity card.
So auto increment is not the right idea. You mean to say, correct?
Right, not the right idea in the scenario, like sometimes you have to uh, delete some records in your fact table. If
Okay.
once you are inserting a record into your fact table, there is no chance to delete any record. Yes, you can go ahead.
Yeah, because it doesn't allow, right? Basically, because there is a relationship between the primary and foreign key.
Yeah, so you have to first delete those records, and there is something.
Yeah, you have to delete both of them parallelly. Mm.
Yeah, yes, yes. No, no, no. So it will allow here in the fact table. It will allow. For example,
Mm.
if you are trying to delete a record in the customer table, okay, on the primary key column, if you are trying to delete, first it will tell you first delete the records in the foreign key.
Right.
In the,
Correct. Yeah.
it's a reverse what you are thinking.
Yeah, exactly. That's a way even I'm thinking.
Delete
Yeah.
it in back table, but you can't delete in the primary key table.
Okay, so this surrogate key is mandatory all the time because business key itself is going to give an identity, right? I mean, unique
Don't
identity.
give identity
So
because
why would we need this surrogate key?
yeah. So in OLTP systems, the customer ID definitely will give identity. Means it will give uniqueness for your row because you have a primary key, right? Primary key means it don't allow any duplicate values and it don't allow any null values. But here, if you are coming to the dim customer, this is not a primary key. We are not creating any primary key property on the customer ID, right?
Okay. Yeah.
The customer ID may be repeat. The reason, what is the reason? Sometimes you want to maintain the history also. For example, the customer. So you are a new customer to a particular bank. You have an account number. Okay. So that information we are going to maintain in the account table, right? The first time whenever you are coming to my bank and you are opening one bank account and account number, what is the account holder name and what is the address. Got it?
Mhm.
So the second day you are coming to my bank, this is my bank OLTP system, and the second day you are coming to my bank and you are raising one request. You don't need to come to the bank and directly you can open your internet banking and you can request the change address. After 6 months you are changing your address, right?
Yeah.
So whenever you are raising one request, the information will come and store in the OLTP table, that is customer table, whatever. Okay, so that
Mhm.
data we are going to load into dim customer. What will happen? The bank wants to maintain the old address as well as new address. They don't want to override and they don't want to delete the old address. For tracking purpose, they want to maintain old address, your old address as well as new address. So in that situation what will happen? See here, the customer key is, first time whenever you are coming to the bank, the customer key I want to maintain 1 and the customer ID I want to maintain 100 and the customer name is something, okay, RAM, and the address is something. The second time you have changed for the request, your address request. So this time the customer key is 2 and your customer ID is same and your name is same, the address is different. The address is different. So how you know which address is the current address, which record is the current record of this customer? So for that reason we are going to maintain one which record is the active. So this is expired record, this is new record. So you can maintain any other flag, yes or no, like that. This is
Okay.
slowly change.
But how does the first customer, the transaction, sorry, OLTP database or table,
Yeah,
how did it accept it? Because you mentioned there is a primary key on top of the CID in the transactional table, that table, right? So master
yeah, I'm
table.
just giving
So
example, I'm just
yeah, right. I just wanted to understand what is the difference between business key and surrogate key.
yes. See, the customer table, whenever you are raising a request, they don't keep that value in the customer table. They are maintaining some rough table, okay, some for taking the requests. Okay, I'm just
Okay.
giving example. In the OLTP system, they are maintaining one table. Inside the table, they are maintaining request informations. For example, you have a customer, sorry, you have a customer care. You are raising some requests. Okay, so whenever you are raising the request, so there is one more table is there, and only for request information they want to track. Okay, so we are going to load this data into some here. So from the request table, so what request we are getting? For example, a customer ID 100 request we are coming. Okay, so this information we have to load into this table. Okay, right. So now your doubt is customer key. On this customer key, I told you, right? It's a kind of technically it's a primary. So that is the reason, and it's automatic increment. Every time whenever the new record is coming to insert, it will blindly take a new value. So this is the column we are going to maintain uniqueness. Okay, so
Okay.
this
Yeah,
that's the
yeah.
reason. If you want to maintain the history as well for a particular customer, yes, definitely the customer ID will repeat. So that is the reason we are not maintaining the primary key column on the customer ID. So why we are calling this is a business key column? Because this is the column we are going to compare with your OLTP system.
Okay, got it. So, but why I'm asking more and more on that is, as per Google, so both of these two IDs, CK and CID, business key and surrogate key, both give the unique identity.
No.
But the business key,
Yeah.
that is sometimes it's a description or something else. So, CKID, the one, what is this? What ID it is? Oh, the
Surrogate.
surrogate key, right? Surrogate key is I mean, it's a kind of GUID or some integer value we are going to mention.
Yes.
So that's the reason the indexing will be little faster if you use any specific I mean key on the surrogate key.
Yes.
Okay, so yeah, we generally while doing any business relationship, so basically we given a CK as a key column and named column as a CID kind of thing. That's I read. That's why I'm asked.
Right. Yeah.
Yeah, you are also right. Yeah, yeah.
Yeah. That's
Go ahead, Ram. Yeah.
right. So the situation up to which level the customer key and customer ID both are same in the sense giving uniqueness is there is a slowly changing dimension.
Mm-hmm.
It's a concept like
Right, SCD. Mm-hmm.
SCD0 that is the first level and SCD1 that is the second level, SCD2 is the third level. Okay, up to SCD second level means SCD0 1 up to 1, yes, though both will maintain the uniqueness. So SCD0 means whenever the new customer is coming, so that customer information it will insert, right? The customer 100 is coming, yes, it will insert. Right now there is a customer key 1 and only the customer ID is 1 time. Clear? Here the customer ID and customer key maintain uniqueness. The second day what will happen? There are two more new customers are coming and already existing customer who 100, the customer ID 100 getting some modification. Okay, his address was changed. So what you have to do, the new two customers you have to insert like 200 and 300 customer IDs, but the existing customer 100 we are going to compare this business key with this primary key with business key. Okay, this 100 already existing in your data warehousing. What you have to do, there is a modification for his address, you have to modify the address, right?
Got it. Yeah.
No need to insert again, we have to modify the record. So what we are going to do here, this address of this 100 we are going to override with the new address. Even this time also for customer ID 100 only one value, we don't maintain a second row for this customer ID. When we are going to maintain the customer ID for this 100, instead of overriding the existing address whenever the record is getting modification, we don't want to disturb the existing one, we want to maintain a new row and to indicate with the flag value.
Okay.
In this
SCD0, right? You are talking about SCD0, right?
SCD2, this is historical
SCD,
information. If you want to maintain history as well as current
the new
information,
record.
that is SCD2. SCD0
Okay.
means whenever the new record, a new customer is coming, it is just allowing to insert that record. SCD1 means whenever the existing customer, how you know this customer is an existing customer or not, based on the customer ID, based on the business key column we are going to compare that particular
Got it. Yeah.
customer ID is there or not. So in that situation, what you want to do, you want to update the existing record or you want to maintain the history, one more record. If you want to maintain a one more record, that is a SCD2. SCD1 means it is just overriding the existing one, but you can't see the history, right? If you want to maintain the history also, in that situation you have to go to SCD2, that's historical information. Okay, right.
Yeah.
So this is the dim customer, and in the same way you have to maintain this key value and business key column for the product table and all those things. The same way, if you are coming to this fact table, in this fact table you have only measure values and key values. So what values you have to maintain? Customer key values, not customer ID values. Product key values, the surrogate keys you have to maintain inside the fact table. Got it?
Yeah.
The relationship is a foreign key relationship based on the customer key with customer key, product key with product table, date key with date table, and some other. So if you want to maintain the, if you want to find out this particular quantity amount belongs to which customer, which product, so you have to join these dimension tables with measure table. So these kind of modeling we are calling dimensional modeling. Under this dimensional modeling, we have two type of schemas. One is star schema, the second one is snowflake schema. Okay, one is star schema and snowflake schema. What is star schema? The star schema is nothing but whatever the dimension tables you have. For example, I have 4 dimension tables and I have one fact table. All the dimension table surrogate key columns. For example, this is customer table, customer key. This is product table, product key. And this is, what is the table? Location table, location key. And this is store table, store key. All these key columns you are going to maintain direct relationship with the fact table. Product key, location key, surrogate, store key, and quantity amount. So this customer key having relationship with this table, and product key having relationship with this table, location table, store table. This looks like a star. Okay, so all the dimension tables having direct relationship with the fact table, so that kind of schema we are calling it's a star schema. And in this kind of schema, the dimension tables are denormalized tables. Denormalized in the sense, for the customer information we are going to maintain only one table. We don't want to maintain 2 tables. If you are going to break up the customer information into 2 tables, that is a normalized tables. The normalized tables are very small tables. So what is the
Properly arranged,
disadvantage?
right? You meant to say?
Come again?
They're properly arranged. You're properly arranged, right?
Yeah, so basically why we are going to normalization, sometimes if you are going to maintain all the customer unnecessary and necessary information in the same table, unnecessary means the data we are going to see very rarely, and the data we are going to update very rare case, like whatever, we don't use that information at the time of survey. For example, if you are going to the survey, at the time of survey we are gathering more information, but the main information is 2 or 3 things only, the major. So that information regularly will update. So that kind of information we are going to maintain in a particular table, and another information we are going to maintain in the another table. That is a child table. You just, okay. So
Good.
here we are going to maintain all the information in one table only. So advantage here is you no need to join multiple tables. For example, if you want to see full information about the customer, if you are maintaining a normalized tables means number of tables. So you have to join this fact table with the customer table, and again the customer table with the customer detail table, one more table. If you are maintaining in multiple tables, the customer information, it's a normalized tables. So instead of maintaining in normalized tables, if you are maintaining here only one table, you don't need to make multiple joins and your query will come very faster the result. Okay,
So in star schema, it's fast, right?
yes, it's fast. One disadvantage is memory. The denormalized tables, these are all denormalized if you want to maintain all the information sometimes. So the denormalized tables will take waste of memory. Those will waste some memory. How? That is the reason we are coming to snowflake schema. So what is a snowflake schema? Any idea?
Uh, it's the normalized form of the schemas. So we are going to split it, and we are going to, from the uh, dimension tables, we are again going to map it to the few more tables.
Right.
Am I right?
If you are coming to this product table, this is the product table, right? So the products basically in a store, they are categorizing these products into first top level categories. If you are going to some Amazon or some Flipkart, you can see these are the home appliances, these are the electronics, these are the something clothing, and there are 5 to 6 categories, main categories are there, right? Then again, if you are clicking on that particular main category, there are some subcategories, and if you are clicking on a particular subcategory, there are different products. Why they are making this? For more accessible. For example, if you don't have category, if you don't have subcategory, I want to purchase a particular kitchen item. So they have almost 5,000 products. So definitely it is difficult to find out that particular product if you don't have category, subcategory. If you have category, yes, I will go to immediately home and kitchen. The item, my item, whatever the item I want to purchase, definitely it will belongs to kitchen. I will go to kitchen, and there is some more subcategory. Okay, so I can easily find out. So that is the reason in my store there is a products is there, and these products belongs to which subcategory. The subcategory information I want to maintain one another subcategory table, and I want to maintain one more category table. So what we are going to do here, instead of making this subcategory table and the category table directly with the fact table, we don't want to maintain any relationship with the fact table. The product table having relationship with the category table, and the subcategory table having relationship with category table. How? In the product table I want to maintain subcategory key column. In the subcategory table we have a subcategory key column, that is primary key, and here we are going to maintain the category key column. So this category key column we are going to maintain in subcategory. So we have a relationship with the foreign key relationship with the primary key column of this category table. Got it?
Yes, got it.
So what is the advantage if you are doing like this way? So one disadvantage is, if you want to see these categories, if you want to see what is the total amount each category wise. So how you can make the data in the fact table, whatever the sales is happen, I want to see each category wise total sales amount. How can we see? So you have to make join this fact table with the product table on product ID and product key and product key, and again this product table you have to join with and surrogate subcategory key with subcategory table subcategory key, and again category table category key, right? So you have to make 1, 2, 3, 4 joins.
Right.
You have to
So
join.
by the way, these joints are inner joints, or what kind of joints these are?
That is you based on your requirement. For example,
Like we wanted to, in this case, in the given example,
yeah,
what you showed me. So those are going to create in the inner join or outer join.
definitely if your schema is good, you have to use inner join. Means, for example, I want to make a join this fact table with product table. Okay.
Mm-hmm.
in this fact table, you have 100 transactions, 100 rows. So in each 100 rows, there is one product key column, definitely, right?
Yeah.
So is it possible, is there any product is missing in the product table?
There won't be because it's a lookup. I mean, it's a all the
Primary
data is
foreign key relationship is there.
yeah, the relationship is there. So
So what exactly the foreign key will do? The foreign key, whenever you are going to insert any record in this fact table, for example, product key column is there. So if we have a relationship with this product fact table, product key and primary key column of the product table, what is that meaning? If you are trying to insert a product key 100, product key 100, so that is belongs to any another like Santur soap. First it will check that 100 Santur is existing in the product table or not. If it is not there, there is a foreign key relation violation, error will come. Okay.
yep.
So that is the reason all the product keys and the products are definitely in the product table. So blindly you can maintain inner join in between the tables. Okay. For example, you have a employee table, you have a department table, okay, and so in the employee table you have department number column. Okay, each employee belongs to which department you are going to maintain, but there is no relationship between these two tables. There is no primary key foreign key relationship on department number column. Okay, so in that situation I have two departments in my organization, department number 10, department number 20. I have 5 employees in my organization, so first 4 employees belongs to department number 10. The 5th employee is belongs to department number 30. By mistakenly I have entered. So whenever you are joining these two tables, the department number 30 is not existing in your department table. That is the reason the 5th employee information don't display in the result whenever you are making join. Am I correct? Inner join.
Yes.
So in that situation, if you want to see all the information about the customers, whether they are belongs to a particular department or not, whatever, I want to see each employee and employee belongs to which department name. So if there is no department belongs to that person, yes, I want to display just null value for the department name. So in that situation, you have to make left join.
Okay. So by default in the data source view, we are okay. Let's go to there. But how can we make? By default, it's going to create the joins behind that, right? So how can we, I
Now,
mean, specifically
joins, whenever
maintain?
you are going to write down the queries, you have to write down the joins, right? By default, it don't make the joins. Whenever you want to see the data, select list of columns from this particular fact table, inner join or left outer join, whatever the join you want to write down, you have to write down the joins, SQL joins. Okay, that is SQL queries.
Okay. Okay. Yeah. Let's see.
Right. So what is the disadvantage about this snowflake schema is you have to make more
Do more
joins
number
on the
of
table.
joins. Yeah.
The advantage is right.
It's a normalized and the little the faster the star schema is the faster one, but consumption of the memory is high, right?
Right, right, right.
And the consumption will be less, I guess, and it will be little slower because of the joins.
Right, we will go more detail how it is consuming the data.
Okay.
Right, I will take one Excel sheet
Yeah.
because without understanding this data warehousing and all these schemas, if we are entering into the designing part, still after 2-3 years also you are in confusion because the base.
Yeah, right. That I can understand. Basics should be strong. Okay,
Yes,
so
yes.
even I would agree.
Yeah, once you are going to the designing, that is 1 or 2 times if you are practicing, good. Because if you are not good in the basics, you can work only for one scheme or one project. Then again, if you are going to the second project, again you have to start from the starting. So if you are good in
Correct.
here basics, then you can work on any project simply. Okay, right. For example, I have the fact table. The fact table having product key, customer key, and some other whatever, and directly I want to take quantity and amount. And I have a product table. The product table having product key and product name and subcategory key column. And I have subcategory table, subcategory key and subcategory name and category key column. And I have a category table, category key and category name. Okay. So we have relationship this category table with wait. This is one table. Sorry, Control Z. And this is another table. This is another table. This is on another table. So the relationships are this fact table having the product key with the product key, and this product table having subcategory key with subcategory key, and this category key with this category key. Okay. So in this situation, if you don't have this kind of relationship, if you have a direct relationship with this subcategory key and category key with the fact table, so how you have to maintain again? So you have to maintain subcategory key and category key. This is the star schema, right?
Right.
This is the star schema. So in that situation, what you have to do? For example, I have a product, I have a categories, two categories, 1, 2, whatever the category names, and I have subcategories 1, 2, 3, 4, 4 subcategories I have. First two subcategories belongs to first category and second belongs to second subcategory. Got it?
Yep.
And now the products I have 1, 2, 3, 4, 5, 6, 7 subcategories. Sorry, 7 products I have. So first two products belongs to this category and second belongs to and this belongs to this, right? So now for example, this is product 1 and this is product 1 transaction, this is product 2 transaction, this is also product 2 transaction, and this is product 3 transaction, this is product 4 transaction. Okay, the customers are purchasing, these are the products. The product 1 purchasing 4 times by different customers or whatever, different customers. Okay, right. If you have so the same time you have to maintain the subcategory information also here. So this product 1 belongs to which subcategory? Subcategory 1, right? So you have to maintain 1, 1, 1, 1. And product 2 belongs to, yes, 1 only, right? Product 3 and 4 belongs to subcategory 2. Am I correct? Product 1
Right.
belongs to, product 1 and 2 belongs to 1, subcategory 1. Product 3 and 4 belongs to subcategory 2. Am I correct?
Yep.
Right. Sorry, product 1 and 2 belongs to 1, and yes, product 3 and 4 belongs to 2 only. Okay, right. So if you observe here and again come to category key. So subcategory 1 belongs to 1 and 2 belongs to category 1 only. See here, subcategory 1 and 2 belongs to category 1 only. So you have to maintain here 1. Got it?
Yep.
So what will happen here? It is repeating how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times the category. So this is a,
Okay. So you mean to say the duplicates are data duplication is high. That's the reason it's a consumes little
yeah. So
higher.
yeah. So basically, if you are going to maintain this category key and subcategory key, if you have 1 crore transactions, the category key you have to maintain 1 crore times. If you have 1 crore transactions, the subcategory key values you have to maintain 1 crore key values, right? If you are going to
Yep.
maintain the subcategory column, category column. If you don't have this direct relationship, there is no concept this one. So in that situation, only how many products you have. For example, I have 100 products. Only the 100 times the circuit key we are going to maintain. How many subcategories you have? For example, 50 subcategories. Only the 50 times the category key will repeat. Got it?
Yeah.
So that is the reason sometimes we are going to snowflake schema. But it will impact on the performance. Because you have to make every time the joins with this table and this table and this table.
Right.
Understood?
Yeah. Yeah. Got it. Got it. Yeah.
Yeah. So that is the reason we are going to maintain this schema. So this star schema and snowflake schema, whenever we are going to create a cube, you have to design. Okay. So you have to
Yep.
design the cube database. Cube is a database only, but the way it is storing the data, the way it is processing the data is different compared to our normal two-dimensional SQL Server database. So for this SQL Server also, normal data warehousing also, we need a schema. That is the schema we are designing star and snowflake to design the database, to create the database. The same way, for designing this database and schema, the data modeler is using which tool? Erwin data modeling or Visio, some other tools. So if you want to design the cube database, what tool you have to use? The tool is nothing but SSAS, SQL Server Analysis Services. This is the tool you are going to use to design the database. That's all. We don't use any other tools. SSAS is the tool to design the database. That's all. Got the point?
Yeah. Yeah. Got it.
Here, the Erwin tool and Visio tool, the same way SSAS to design the cube database. So whenever we are going to create this cube database, 3 levels. First, you forget about the target. The source is important. From where you are going to take the data and from where you are going to import the data, from where you are going to import the structure and tables if you have already the system. The star schema and snowflake, any of one schema is already in your source. Yes, well and good. Directly you can import that. Okay. So first you have to be clear about the source. Then after creating the data source connection, this data source connection will store the connection information about your data source. Then coming to data source view. So you can see what you have in your data source. What are the tables you have in your data source? And if you want to make some relationships and if you want to do some manipulations, these kind of, if you want to design a predefined schema, here you can design the star schema or snowflake schema. Why we are using this data source view is to simplify the cube designing. To simplify the cube designing, this is the pre-step. This is one step before the cube designing. So then after, whatever the schema you are designing in the data source view, directly you can use that schema for the cube designing. So once your cube designing is done in your SSAS, these three steps we are doing in SQL Server data tools. Inside the template is multi-dimensional multi-dimensional model. So you are just designing the database like in Irwin data modeling. After designing, what he is doing, he is just giving the scripts and you are executing the scripts in your SQL Server. Then it's creating the database. After you are designing this database, cube database, you have to deploy and you have to run this, you have to deploy this cube database in your SQL Server analysis services. Just go to connect analysis.
So in between the DSV and cube,
Yeah.
so but this dimension is going to come, right? So we have to create the dimension first or cube first?
See, already if we have dimensions in your source, data source view, okay, you
Yeah,
don't need
yeah.
to separately create the dimensions in your cube. Automatically from that data source view, the tables will come and add into your cube dimensions.
Okay, so yeah, okay. So the cube dimension by default it's okay.
Yeah,
We
there are two steps.
specify those.
There are two steps. At the time of designing the cube, directly if you want to import the dimension tables and fact tables from your data source view, yes, you no need to add any dimensions separately for your cube. At
Got
the
it.
time of creating the cube, if you want to just taking one empty cube, later if you want to add the dimensions, yes, you have to add the dimensions manually. In that situation, you don't require data source view, right?
Right, right.
Data
Got
source
it.
view
So
is for simplifying the cube designing. Okay, right. So this is the cube database, and if you want to design, if you whatever the schema you have designed over in a cube, that you have to deploy here in the under the database section. Okay, right. So now come to here. There are two kind of modelings we have. Modelings in the sense, one is multi-dimensional and the second one is tabular model. The tabular model is coming in 2012. In 2008, this is in 2005 and 2008 are
and I am not
still
sure.
used. Okay, the tabular model is only coming in 2012. Okay. So what exactly the difference between this multi-dimensional and tabular? Simply in memory. The tabular model is a in-memory model, and the multi-dimensional model is a, it is working, it is storing the information either in a disk or a database or whatever. It is not in memory. Okay, and so the tabular model is working based on the engine, that is Vertipax engine. Vertipax.
So both the things that does the same thing, right? Both the approaches does the same thing, right? In terms of design and development, only the engine and the consumption of the memory is going to vary, correct?
Yes, the engine, the engine and the memory storage is different. The tabular
Yeah,
model will store the information in the in memory. So in memory is
yeah,
faster than our normal disk storage, right? The
yes,
multi-dimensional don't have any in memory. Okay. For example, you have a report. So whenever you want to display the data in a report from this multi-dimensional, Every time it has to take the data from your database, cube database.
Correct.
But the tabular model will store the information in memory. There is an
So is it not
yeah,
going to create any database for it? So if in case if you create a multi-dimensional model, SSAS,
okay.
so it's going to create a database, right? It's going to
Right.
create
So
a
whatever, yeah, that is the reason I told you, right? So whatever the cube we have designed in SSAS, the tool only for designing the cube database. After you are
yes,
designing, you have to same under the databases. These are the normal data warehousing database, right? The same way,
right.
this is the cube analysis services. Under analysis services, under the databases, you have to maintain the database.
So in case of my question is in case of tabular, is it going to create the same kind of database?
Definitely, it is going to create a tabular database, but
Then
the data
in
is
memory,
in
where it's
memory.
going to come into picture?
The data is in memory. There are two options. Either you can use the tabular data modeler for the in-memory purpose, or you can directly query. There are two options. Okay, but inside the engine is different. This is a vertipax engine. So this is instead of taking the row wise data, it will store the data in column wise in the in memory. Okay, you know that in recently in 2012, the index type is coming column store indexes. The previously we have, yeah, of course, right now also we have row wise indexes. For example, this is the product table. Okay, in the product table, what will happen whenever you are creating the indexes? For example, a cluster index you have created on the primary key column, this column. Okay, so it will store the information in row wise, the indexes, the primary, the clustered index will store on the table only. So that is a different concept in the indexes. Okay, like for example, in a database, this is a database. Inside the database, how the data it is going to store?
In row and column basis, column and rows.
Yeah, that is the thing we know as a developer. But
Right.
right, so basically as a developer, how he is thinking, yes, we are creating a table here and we are storing the data inside the table. Okay, so that is just for our understanding purpose only, but actually the data how it is going to store inside a database is like a pages. This is a database. Whenever you are creating the database, so you are giving some memory, right? So for example, 3 GB or 4 GB or some whatever. So what it will do, it will split your 3 GB or 4 GB into each page. Okay, each pages, each page having 8 KB of data. Okay, 8 KB of data, and 8 pages we are calling one extent. The group of 8 pages we are calling is a one extent. 8 into 8, 64 KB is called one extent. So in one extent we can store 64 KB of data. One extent is nothing but 8 pages. Each page having 8 KB of data, it can store. For example, if you are creating a table, okay, so the table will occupy some pages. Inside the table, you are inserting, for example, 5 rows. How much space the 5 rows will take? So first it will insert the data into one page. So for example, this page will occupy only 8 KB. After, it will jump into next page, and then it will jump into next page. Okay, right. Total in a table, you have 10 rows. So whenever you are creating the indexes, the pages are coming like this, right? The index will store in first page and the second page row wise. These are the 5 rows, and inside these 5 rows. For example, in this each page we have employee number, for example, employee name, salary. If you want employee name column, select employee name, from employee table. How it will take the data? First it will bring the data from this index table into memory. From that memory it is going to display the data. So whenever it is going to fetch, it will fetch all employee number, employee name, salary from the your index database into in memory. It don't bring only employee name column. That is the disadvantage of the row index. So that is the reason in 2012 they are introducing column store index. How it is storing? It will store each column wise. The indexes will store each column wise. For example, this is employee number, this is employee name, this is whatever the column you are fetching, only that column it is fetching into memory. So these column store index also working on Vertipax engine only. Whatever the engine is working for tabular model, the same engine will work in column store index. Got it? Okay. Okay, that is a different topic, so we just ignore that one. So so basically this tabular modeling, it's very easy. Okay, it's very easy. When we are comparing with the multi-dimensional, the tabular model is very easy. Okay.
The design and development is not going to vary anything, right? So in case of tabular model, it's an engine and the remaining things are going to vary.
Yeah, the schema is same and bit easy when comparing with the multi-dimensional. We don't have that much of KPIs and that much of things. Okay. So we can create in the tabular modeler only the calculations, the KPIs and hierarchies. That's all. You can't do anything more than that. But in the multi-dimensional, yes, you can do more thing. Yeah, partitions also you can do in the tabular modeler.
Okay.
So you can't do more than that in the tabular. Okay, right. So multi-dimension is the primary thing for us. Okay, right. So you just go to file, new project. See here, which one you want to select? Analysis services multi-dimensional data or analysis services tabular project. Whenever you are installing your this SQL Server MSBA software, you have to specify. You can't use both. Either you want to install the software under the multi-dimensional model or tabular project. Which one? Any of one only you can select. For example, if you are installing this one under analysis services tabular project, you can't deploy this analysis service multi-dimensional modeling. You can't use this one. Okay. So any of one only you can choose. Okay, right.
So suppose I install using a multi-dimensional. If I create then a tabular project, is it not going to work now?
Yeah, it don't work.
Okay.
Okay.
Right. I should have removed this tab.
Yeah. So analysis service multi-dimensional I want to use, and the project name I want to give whatever. Okay. SSAS project. This is the storage location. Click OK. So actually I have installed this in under tabular model.
Okay.
So whenever we are going to do deployment, I will take another mission. I have another mission. So I will do that on mission. Okay. Right. So you just come to Solution Explorer. This is my project. The first thing what we have to do, create the data source, new data source. Click next. And so what is the data source connection you want to create? If you want to create a new one, it's already there. I have created in the long back. So if you want to take new one, yes, you can take new one. I want to use the existing old one only. Okay. So right, click next. So here the information, whatever the username and password you are going to specify over here, so that information should be access on your data source. For example, your data source is any of one database in SQL Server or whatever, but the account, whatever the account you are going to specify username password should be should be having access on that particular database, read access. Okay, so use a specific Windows username and password. Whatever the username and password you are giving, that should be accessed. Whatever this service account, so instead of providing the username and password, you are just simply taking service account. Service account means this analysis services, not only the analysis services, any of services in your computer should run under one account, right? At the time of
Right.
installation, this analysis services SSAS is going to run under one services. You can check, you just go to services.msc and which account this service is running. So if you are selecting this one, it is using that service account to connect to database, but it's not mandatory this service account should have access on this database, right? Or
Right.
you can use credentials for the current user. I have logged in with into my computer by using some username and password. You want to use that one? I'm not sure. This user account having privileges into my data source. Okay, and or you want to inherit. Inherit means yes, the same the current user information only it is going to take, but it don't have that much of features. Okay, so instead of these three options, just specify the username and password, who whatever the account having privileges on your data source. Okay, right, so this is the information I want to use. The data source name you can give anything, finish it. The data source is created. Okay, if you want to, so the if you are coming to the options, if you want to copy this and if you want to make one more, yes, paste it. If you want to give another name, yes, give it. So you just copy these data sources also. If you want to delete, yes. What is the difference between exclude from and delete?
Exclude, still it will be there inside the same project. I mean, it will be there under the same folder. If you wanted to add it in future, you
Yes.
can add it. If you are going to delete it, physically it removes from the folder also.
As well as in your folder.
Yes.
Right. So the next thing is okay, done. Your data source connection is created. So if you are coming to the data source view, you can create many number of data sources. Come to data source view. Click next. So these are the list of data sources already you have created. Okay, right. So I want to use this data source, already created data source. Click next. Here there are three options. Whenever you are going to see or you are going to import the tables from your data source, for example, I have a dim customer in my data source, whatever the connection I have taken. So create a logical relationships by matching columns. So what I am going to tell here, in dim customer, I have a customer key. In fact table, I have customer key. If the column names are both are same, yes, I am telling create automatic relationship. If you don't have relationships, got it? Automatically it will create the relationship if the column names are same. Same name as primary key. In your dim customer table, you have a primary key. You have a primary key, and the primary in any of another table, if you have the same column name, so I want to make the primary key. That is the first, same name as primary key and same name as destination table. So whether it has a primary key or not, so the main thing in these three options are the relationships, automatic relationship. Okay, the destination table name is, for example, whatever the table you are going to import from your source, and in your data source view also the table name will come as usual table name. You don't change anything. Okay, right. So but you just ignore this one. It's not an
But this is not working in case of Oracle. It is working only based on the SQL, right? So if you have any data source of SQL or Microsoft SQL, it's working. In my case, I tried with the Oracle data source. It's not useful.
okay, okay, I think so. Baby, for
Yeah,
Ariki,
maybe I think it's not identifying the I mean the relationship or whatever.
okay, okay, right, right. So yeah, so that is the reason the SQL server most of the time for the different data sources it may not support most of the options in this one.
Right.
Okay,
Correct.
that is the reason. First, they are what they are doing. They are migrating the databases into SQL server. Then they want to design anything further.
Correct. Yeah. That's what they are doing now. Yeah.
Okay, right. Just click next. Okay, you just keep this one for SQL server only. It will take the
Yeah.
relationship, automatic relationships. Okay, right. So these are the list of the tables you have in your data source in my database. Okay. So if you have
Yeah.
100 of the tables, what tables you want to take for your data source view and for the cube designing? The first primary focus on fact table. If you don't know what exactly the fact table, you just type it fact and search it. It will display only that fact table. Okay, I want to take this table first, right? So what about the remaining tables for designing this schema? If you don't know, this fact table already having some relationship with the some dimension tables. What are the dimension tables? If you don't know, you just click on the add related tables. Automatically it will add that tables. See, add related tables. Only this salesperson stores customer table having relationship. This dim product table don't have relationship. No problem. I will take and I will create the relationship in data source view. Take it. And this dim date, I want to make the relationship. Take it. That's all. I don't want to take the dim time as of now. Okay. So you just come to the next. So what is the data source view name you want to give? These are the list of the tables coming under data source view. Finish it. Okay. See here. These are the list of tables. Right. So already having relationship between the dim stores and salesperson also. This is a bad design for the cube. I want to remove this relationship.
Yeah. Why do we need that kind of relationship in case do we use like that anytime?
Sometimes if you want to,
Dimension to dimension also?
no, 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 yeah, that is a bad design actually. So
Okay.
if you, for example, if you want to see, for example, each store wise the total sales persons. So there is a relationship between store ID and store ID.
Okay.
So that is a bad design.
But everything, yeah, okay, but everything will be popped up from the fact table only, right? So,
No, yeah, so if you want to see each store in each store how many uh, salespersons, how many employees are there in the fact table, it is difficult to come in the fact table. Only it will track transactional information. Okay, you
okay,
don't know, for example, in a particular store there are 5 employees are there, only 4 employees are doing the some sales, another employee is not doing the sales. In that situation what will happen? The information not coming into fact table, right? The fifth employee.
yeah, generally we drag the store information first, and if you drag the salesperson information next means, so anyway, those are joined with the fact tables and it get the information, right? Am I right or wrong?
Come again.
Now, even if you don't make the link between store and person, salesperson,
Okay,
so we are going to get the same kind of result, right?
yes, result, the same kind of result will come, but the information whenever you are going to insert into the store table and sales person table, it is not dependency like primary key, foreign key. So
Yeah,
what exactly the foreign key? it will avoid the records if you are trying to insert whatever the records are not existing in the primary key column. For the employee table, if you are trying to insert a department number, that department number should be existing in the department table if you have a foreign key relationship.
Got it. Yeah.
Okay, right. So you just remove, because our target here is I want to design a snowflake schema, sorry, star schema.
Yeah.
Okay, right. So already I have relationships between this fact table and this dim customer table and salesperson table and store table. So I didn't create this relationships between this product table and fact table and date table and fact table. Okay, so if you want to see the existing relationship, you just double click on these links. See, customer ID from the fact table and dim customer table customer ID. Yes, okay, fine. If you want to make it reverse, yes, you can make it reverse. Click OK. So now our goal is I want to create this product table relationship with the fact table. So you just see, is there any product ID column? Yes, this is the product ID. You just drag and drop on this product table. So before that, we have to do one thing. This dim product table, okay, this dim product table or whatever any dimension table don't have primary key column in your source table. Whenever you are going to import this dim product table or store table, if that table don't have a primary key, so what you have to do? You have to create a primary key over in the data source view. How can you create? You just right click, set logical primary key. On which column you want to create the logical primary key?
Can there be a dimension table without primary key also?
Right. Yes, you can take the dimension table without primary key also, but the problem will come. What kind of problem will come? Right. So yesterday you were facing some problem, right? So what is that problem? Okay, I have the table, product table, product key, product ID and product name and whatever the column. Okay, so the product key is 1 2 3 4 5. Okay, and this is product ID is something like P1 C1. It may not be anything because in this table you don't have any primary key. The data may be repeat. Okay, right. This product name something, this is something, this is something. So what will happen if you don't have primary key? It may be repeat. If you don't have primary key, it may be repeat. Got the point?
Yeah.
So whenever you are going to load this kind of data into cube database, it will throw the error. What error? There is a duplicate key in your dimension dim product.
Right.
So each value, for example, whenever you are going to load this column, or whenever you are going to load this column, or whenever you are going to load this column, there is two values you have to specify. One is key column, the second one is name column, and the third one is value column. Am I right?
Yeah.
So the key column, for example, when it is going to load this data, this dimension data, the cube will form a query. What query? For fetching the data from your data source, it will form one query. That query is select distinct. Okay, select distinct whatever the column. For example, if you are going to load the product name column, this column name from the table, this table. So in that situation, yes, the data will come whatever the values, distinct values if you have, yes, it will take the distinct values, but the key column should be distinct. The key column, each value, it should be identify the
The distinct value.
Yeah, this primary key column is going to refer the key column is the any of one column, that is a primary key column. The name column you can put anything, primary product name or value, what are the values you want to display in that column. Yes, you can take these values, but each value it is going to make unique. You have to maintain any of one column, otherwise.
So basically, Ram, one question here is why, when do we specify name column and when do we specify value? Generally, I didn't specify any value column.
You don't need to
So what
specify.
makes the difference? What the difference? When do we specify it?
You no need to specify at the time of this dimension, because if we have a primary key column, automatically whenever you are designing the schema and after that cube designing, whenever you are going to load the data, each column, non-primary key columns, non-key columns will refer the key column as a primary key column automatically.
I'm asking about the value column, right? Value column. What is name
Value
column and
column is
value?
nothing but the value column is nothing but this primary, sorry, whatever the column you are going to load. For example, product name, default it will take whatever the name column is there, that is the value column only.
Okay.
The value column is nothing but what values, in which column values you want to take.
Okay.
Okay, KJJS or DDDS, FRDS, whatever the values you have here, those values only I want to take over here. Got the point? If we have primary key, each column will refer the primary key column as a key column to identifying each value distinctly. Uniqueness. Okay, and one more thing here. So you don't have any duplicate values over here. For example, here you don't have any value, and here you have null value. Okay, here you have null value, and you don't have any primary key column. Okay, so in that situation, whenever you are going to load the this name product name column, the key column is product name only. The name column is product name only. Am I right? And the value column also product name only. Right. So after you are fetching, whenever it is writing the query to take the data from data source view, what query it will return? Select distinct product names from the product table. Am I right? So what are the values will come? Distinct values, one empty value. This is one value, and this is another value. This is another value, and null also another value. All the values are distinct values. Clear?
Right.
All the values it will take. There is no duplicates here. All are different values. But after it is taking the data from data source view, what it will do, the queue, the null value it will automatically convert into empty string. Got the point? So then this already one empty value is there, one more null value is coming as a empty value. So there is a duplicate. Whenever it is going to process the data into cube, it will make duplicates. In that situation also, it will display the error same like there is a duplicate key value in the dim product table. Whenever you are going to process the data, it will fail.
Right.
Got the point? This is the second reason we are getting the same error. So how can we avoid this one? You can eliminate the information whatever you have in your source table. Null values if you don't want to take, yes, you can avoid. So that is the reason you are going to create a primary key column. This is the one solution for all this. If you have proper primary key column, for each column the key column is a primary key column only. Automatically it will take. I will show you.
Okay. Before going into it, Can you show me in DSV how can we mention the columns? Like we are discussing something in the DSV, right? So I just wanted to
Definitely,
see if I have.
definitely.
Yeah.
Right. So
Yeah,
one thing,
like how can I mention the where condition?
yeah.
Like I wanted to in the fact table I wanted to receive only for the few values.
Okay,
Okay, how can I mention that specific query?
got it. So one more thing, one more point I want to discuss over here. So
Sure.
this is the string data, right? The
Yeah,
values are null values. This is a empty value, and the null value will convert automatically empty. If it is
right.
integer, for example, instead of product name, I want to take some ID column, whatever, 1, 2, 3, 4 like this. So is there already one zero value is there, and there is one null value is coming. So for integers, the null value convert into automatically zero.
Okay.
Then it will make a duplicate.
Okay, okay, got it. So if it is an integer, it's going to be become 0. If it is string, it's going to be become empty.
Yes. Okay.
Yeah,
Automatic. Right. Now come to our DSV. For example, right, I want to make this dim date also the relationship on sales date key with date ID. Okay. So
mhm,
the relationship you want to change. Yes, you can change over here. Okay, right. So now in this dim product table, I don't want to take any of two columns. For example, this product sales cost I don't require. I don't want to take. If you want to remove this column, how can you remove? And also, I want to make a calculated column. How did you make the calculated column? So you just right click, new named calculation. You are making the calculated column by using any of the, for example, this product sales cost I want to make 10% more for each product.
right.
Okay, product cost, new cost, and I want to multiply product sales cost into I want to make 10. Click OK. So the calculated column is coming. This is quite different when we are comparing with the remaining columns. I want to eliminate this old cost, the product sales cost. How can you eliminate? This is new cost I have calculated based on the old cost. If you want to remove this one, how can you remove?
Right click. It's
So you
not there.
right click, you just right click. You can't directly delete the column. Right
Okay.
click, go to replace table with new named query. Okay, so we are taking all the tables directly from our data source, right? So instead,
Right.
at that time we don't have a chance to select the column names, what columns to take.
Right. Exactly.
So that is the reason we are going to convert this table into a query, named query. So in this query, what columns you want, so that columns you can select. I don't want this product sales cost, and I don't want product actual cost also.
Right.
See, only these columns I want to take and my calculated column. Click OK.
So this is where the place we mention the where condition also,
Yes.
right?
Even for, okay, I want to edit again. So this is the place you can write down where I want to take only a, so you can write down the where condition.
Perfect. Yeah.
Where the product alternate key, where the product name equal to Santur, I want to take only product Santur. You can specify the where condition over here. Got the point?
Yeah. Yeah. Got it.
Then click OK. So what are the options we have here? If you want to make a relationship, different ways you can make the relationship. Directly you can drag and drop here, or you can right click on which table, new relationship. So you can select the tables and you can select the column names over here. Okay. And if you want to make replace table with a new named query or with another table, yes, you can replace like this way. If you want to delete this table, yes, delete the table from DSV. If you want to see the data,
And
yeah,
yeah, by default it's going to with I mean earlier we discussed about it. By default it's going to make an inner join with all the tables. So by if I wanted to make outer join with any of the table, I mean I have a separate table. I wanted to make a relationship with the product table as in a left outer join table. So how can I make that?
there is no left and right join concept in Q. Okay, there is no,
Okay.
yeah, there is no
By default it's going to be always inner join.
matched records.
It's a matched records only, right?
Only
So
match.
but okay, yeah.
Right. So there is one more level in cube. So this is the just for creating the relationships, and there are different relationship types we have in cube design. Okay. So we can discuss there if there is any chance to design this left or something kind of joins.
Okay.
Okay. Right. So this is the basic data source view, and these are the all the options we have. Okay. And if you, for example, if your schema is a huge amount of schema, so you just zoom it. Okay. And if you want to make,
So here we have one more concept, right? Named query and named table, right? So we can create our own table with the named something like named table. Huh? Something is there.
so we have already the first time whenever you are importing the table you have taken from the data source. If you want to
Right.
convert this data, if you want to convert this table into a query, yes, you just right click on the dimension and replace table with new named query.
Right. That is right. Along with the new named query, we have any concept like you can create the element or you can also create your own new table, right? When do we create the new table basically?
New table, no. So what if you don't have a particular structure in your data source? So you are already, this is well defined structure in your data source,
Right.
all these tables and the column names and all structure is there, then you are importing simply.
Correct.
Okay.
But there is a concept called you can name tables, right? So
There,
yeah,
that new name table is not there.
name table. I think not here. Okay, the first tab and the same thing. Go to first tab. Yeah,
This one.
I think is okay. I saw somewhere in the video. Hmm, I don't know what. Yeah, named query. What is the left one? Named query next. The left one.
This is a new diagram.
Oh, sorry. Yeah, name somewhere it's there. Okay, here I will ask that question later. We'll
Okay.
check that.
Already whatever the tables you have, if you want to find out the tables, find the tables in your data source view. If you want to add a new table, how can you add? Just right click, add a table. But the table should be coming from your data source view. So that is one disadvantage definitely here. If I want to create a new table, yes, and if they are giving a chance to design a table also, like what is the table name I want to give, and I want to add 3 columns, it is good, right? So but we don't have
Yeah.
option that one here.
Okay.
Okay, so these are the options we have. For example, yeah, this is a schema. If you have this a lot of schema, it's a big schema, you can't see in one window, right? For example, you have to scroll up this one. In that situation, just come to this arrow mark, so you just move like this way. In a single point of view you can view the schema. Okay,
Got it.
so these are the things in data source view level.
So here we write the new named column, right? Named query, right? So that language, is it going to vary based on the data sources? What I observed is, okay, I had a scenario. I have to concatenate the values.
Okay.
Like if my data source is different, if I use the data source as in our MS SQL,
Okay.
So we have to write the different query. If I use a different query like Oracle data source, I
Yes,
have to write the different thing. So is it something different? Is it going to vary based on the language
definitely.
data source?
Definitely. Whatever the syntax we have written here, that syntax should be match your source system.
Source system, is it? Okay.
Okay. Right.
Yeah.
So I think the concatenation in Oracle is different and SQL is different, right?
Yeah, we have to write a function like concat and we have to give it like that.
Yeah.
So earlier I tried some time for with the SQL query, but it did not work.
Yes, yes. Even though call seg functions and these kind of functions you have to use if you want to remove
Okay.
null values. Okay, right. So this is about the data
Yeah.
source view, and make sure the primary key columns and make sure the relationships. That is the primary thing. Okay. Now if you are coming to the cube, just right click new cube, click next. So do you want to create a cube with the already existing tables? Already existing means you have already in the data source view level, right?
Right.
Or you want to create an empty cube and later you want to add the tables? So that is the thing you did, I think. You are adding a cube.
Which one? I didn't create any cube. I just created the dimension.
Okay, 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 right.
First, initially, I thought of creating the dimension. Then after that, with the dimension, I thought of creating the cube.
No, whatever the data source is, you have already from the data source, you can import the dimensions and facts over there.
Yeah.
Okay, right. We
Yeah,
will.
initially I thought of starting with the dimension first, then after that creating the cube based out of that.
Okay.
But yeah, okay, I can do that.
If you are good in your data source view level, then directly you can create a cube by using the
Okay.
tables. Okay, right. I want to use this uh, existing tables. And what about this generate tables in the data source view? Okay, so this is for just for their SQL server. They are giving some predefined templates. This is not suitable for all the projects. Okay, it is a kind of sales projects or some supermarkets. They are giving some sample. Okay, sample templates to design the schemas, product table, customer table.
Mhm.
Okay, we don't use this one. So if you want to create an empty cube, later you have to add the dimensions instead of adding that one. So whenever you are going to create the cube, so you just add by using the data source view the tables, fact table and dimension table. Okay, so I want to use the existing tables only. Click next. See here, these
Okay.
are the list of tables in your data source view.
Right.
Here you have to identify the what is the fact table. And from which data source you want to take this? I have only one data source that is created here. You can create multiple data source views. Okay, right. So here which tables are fact tables and measure tables in this?
The one which is mentioned in the fact as a fact and dim is the dimension tables,
Right.
right?
So that is the reason we have given. Okay, if you don't know which table is a fact, which table is a dimension table, you can ask the suggestion. You can ask the suggestion. So you just click on suggest. It is telling a dim date also you can consider as a fact table. It's wrong,
Oh.
right? So
Mhm.
all the every time it don't give proper suggestions. Okay, so I don't want to take any suggestions from the SQL server. Okay, this is the,
So
here you have to
this is
select.
the
Yeah,
only fact table do we have to select, is it?
yes. So we are going to differentiate what are the tables facts, what are the dimension tables.
Right.
Okay, based on that the cube will consider these are the dimensions, these are the facts. Okay,
Mm-hmm.
right. So just come to next. Or sometimes in this dim product table we have deleted two columns, right? Actual cost. sales cost, right? If you have those
Yes.
two columns, it will suggest you the dim product also one fact table. You can consider, see, one table you can use either fact table, either dimension table in the cube. That is the one advantage. A
Huh.
single table can act as a fact table as well as dimension table. Best example is dim product.
So when we call it like that, when it becomes an both,
Right. So in the dim product table, you have the product actual cost, right?
right?
So your analysis, I want to see each product wise actual cost and sales cost. In that situation, if you want to do some analysis, if you want to create some measures more on this product table, yes, you can treat this table as a fact table also. So that is the reason what I want to do. I want to create this is a fact table also. It will be there in the fact table as well as dimension. This is the step we are going to tell these two tables I want to treat as a measure tables. But we have to be clear before what are the dimension table, what are the fact tables. Okay, this is the one situation sometimes we are going to treat a dimension table as a fact table also. Okay, you just come to next step. See here, these are the list of columns from the first table, first fact table and second this table. See, it is taking only measure values from the dim product. Actually, in the dim product, you have product name is there, you have product key is there, product ID is there, but it is taking only product cost new and dim product count. Count means each product wise how many, what are the count? It is just it's a basic aggregated value, right? Count is the, so that is the reason
Right.
automatically it is creating the dim product count also. Each product wise what is the count? Okay, right. In this fact table, these are all the quantity, sales, total cost, product. What columns, what measure values you want? Yes, you just take those measure values only. I don't
Okay.
want transaction ID. I don't want sales invoice number. I don't want sales time key. I don't want sales time
These
update.
things we can once even if we create with the all the values, we can remove it later, right?
You can hide it. You can't remove. You can hide it.
Okay.
Okay, right. Yeah. So whenever you are going to add into your cube, yes, you can. Okay, we'll see. We'll see in the next step. Okay, click next. I have added all. Okay, here you have to specify what are the dimension tables. Okay, at least one dimension, at least one measure definitely you have to take for the cube designing. So these are the dimension tables. I want to take all the dimensions. Click next. See, this is the final thing. Two are measure tables. These are the dimension tables. Got the point?
Yep.
Finish it. The cube name what you want to give, you can give here. Finish it. See, this is the structure is coming. This is the data source view. This is the data source view and this is the cube. Okay, I want to close this data source view. Right, this is the cube. This is not a cube. This is just data source view only. Whatever you have designed your data source view.
Right. The same thing came here, right?
Yeah, your actual cube is this one. These are the measure tables. These are the dimension tables. Okay.
So Ram, in my case, there are two, right? Measures. Like there is one measure group, and under that there are two measures. So for that, I just need to select the value from the fact tables, right? Do I have to create anything explicitly?
We have only one fact table, right?
I have only one fact table. There is a measure group. Okay. The measure group contain two measures.
Measure group is a table or it's a attribute. It's a column.
It's attribute. It's a attribute.
So what you have only one table and inside the table that is fact table, inside the fact table you have two columns, right?
Right.
Okay, so that will come under here. See, this is
Yeah,
I
that
have
one.
two fact tables. Under this fact table, these are the columns.
Measure group. I'm asking measure group. This is going to be measure group.
Yeah, these are the measure groups. The measure group means how many tables you have. These are the two measure tables.
Okay, okay, okay.
Fact
The
table.
measure is nothing but the fact table we call it,
Yes.
right? Okay.
Okay. And these are the
Yeah.
dimension tables. Below are the dimension tables. See this.
Got it, got it. Perfect. Yeah, got it.
Okay. Right. So the fact table, whenever you are creating the cube database, there is a chance to select what columns you want to add to cube, right? See these measure tables. But the dimension tables, we didn't get a chance to select the list of column names from the data source view. Got the point?
Yeah.
So now you have to see what are the columns are added from your data source view to cube dimension table. Come to dimension store attributes. Only store ID is coming. But in the store table, we have a store alternate ID, store name, store location, city, state, country. All these columns you have to add into this cube dimension. And one more thing, whenever you are creating this cube, automatically the dimensions are added over here. You no need to add explicitly, right click and add new dimension.
Okay, okay, got it.
Okay, right. So now I want to add some of the columns from data source view to this cube dim store. So you just click on edit dim stores.
So it will take you to the
This is data source view and this is the cube dimension. So what do you want to do? I want to add store name, just drag and drop over here, store location, city, state, country. Done. Save it. Okay, close it. So in this way you have to do for all the dimensions. What are the columns you required from your data source view? Customer name, I don't know why it is closing.